let's talk now about how the derivative of a function relates to the graph of the original function. So if we graph the function, how does that relate to its derivative here? Right. Let's say, this is x and y directions. Alright, so here we have this function. Remember that the derivative is giving the slope of the function. Okay? So let's look at a few special spots here for this function that we have graphed right here. Right? Specifically this spot, and I think it's about right there, that spot. What do you notice about the slope of the function there? If we were to draw the tangent line there, what would happen? All of these tangent lines are horizontal. So what's the slope of each of these? Right? What's the slope here, for example, at this one? What would the slope be? Well, hopefully you remember that the slope of a horizontal line is 0. So there's no rise in it at all. So what that means is that at each of these spots here, where we have a horizontal tangent, the derivative equals 0, meaning that it crosses the x-axis. Right? Hopefully that makes sense. And now we have to decide, well, okay, so we know where it's going to cross the x-axis at. The question is, what else is it going to do? Let me make this a bit longer. All right, what else is it going to do here? Well, let's look at our function. All right, let's take a point, say, in here. Right? Right here's a tangent line. Is the slope positive or negative here? Well, hopefully you can see here that the slope is less than 0, which means that whatever the derivative is, its value has to be negative. Right here, the tangent line is positive, so the graph has to be above the x-axis. For this whole part here, it's negative. So, sorry, I meant to write this is positive. Here, we have a negative slope. And here, we have a positive slope. All right? So here we have like negative, 0, positive, 0, negative, 0, and then positive again. Another thing I want to ask, how does, say, the slope down here, or maybe over here, how do these three slopes compare? Right, they're all positive. Let me just fill in these zeros. All three of these slopes are positive, but how do they compare to each other? Right? Think about what does a bigger slope versus a smaller slope means. Right? Like, what's the difference between slope 2 and slope 10, for example? Right? Well, the bigger the slope, the more steep the graph is, right? So we want to kind of try and pay attention here. Based off how steep this is how high or low the derivative should get. So like here, up here it's very negative, and then it starts getting towards 0 here. So our derivative probably looks something like this coming up to that point. Maybe we'll make that a bit better. Say something like that. Right, now here, it's going to get a bit positive and then go back to 0. So we're going to go up and then back down. Here, we're negative for quite a while. It never gets too steep, so we won't go down too far. Maybe to about there. And then we got to start making our way back up. Right? And then here, as we go further to the right, this graph keeps getting steeper, so this should keep going up. Right, and this is sort of an example of what f prime of x might look like, what the graph of it might look like. Right? So something I really want to emphasize here is just how these two graphs sort of relate to each other. All right? So again, wherever the function is moving downward, the derivative should be negative because the slope is negative. Wherever the function is moving upward, right, wherever the slope is positive, the derivative should be positive. Wherever the function is sort of turning around at, like here it's turning from going down to up, here from up to down, whenever you see those kind of turning points, that's where the derivative should be 0. In other words, where it crosses the x-axis, or at least touches the x-axis. All right? So that's how the derivative, the original function and the derivative relate to each other. So what I want to do now is talk a little bit about the second derivative. So might have to just pull this onto the next page, which is fine. All right, so let me, oops. All right, see if we can get rid of all the orange stuff here. At least a little bit of it. Oh, let's undo that. Alright. So what we want to talk about next is how does the second derivative graph relate to the original function? Right? That's probably about a little closer. There we go. This is probably about as clean as we're going to get here. So how does the second derivative relate to the first derivative here? Or to the original function and the first derivative? Well, we now know how the graph of a derivative relates to its original function. So let's do the same thing that we did to go from the blue to the red graph, but do it on the red graph to get the second derivative. So here are some horizontal derivatives, right? Where the derivative is 0, some horizontal tangents. So we know that the second derivative should cross here and here. In fact, let me make these green. Right? Right? Here, in this part, the slope is positive. This part it's negative. And this whole part here, it's positive again. Alright, so we're going to do basically what we did last time. Right? So here, we're probably looking at something kind of like this. Right here, it's going to go down and then back up. So something like this. Right? And then now it's going to start going back up, and it's probably going to be going pretty slowly. Maybe something like this. That's the wrong inflection. Probably something like this. Right? So we'll say this is... Move this over. Here's f double prime of x. Right? So, we now have the first, second derivatives of f graphed. Now, I want you to look for a relationship between the blue graph and the green graph here. Right? We know the connection between the red and the green, because that's how we graph the green one. But I want you to look for a connection between the green and the blue graph. So pause the video if you need to think about it. Right? So let's look at something here. So where the green graph, the second derivative, crosses the x-axis, I'm going to draw some lines. Let's see, the green graph's right here. I'm going to draw some lines here. All right. Now, I want you to look at the general shape of the blue graph in each of these three segments here. Okay. So here, in this first segment, the blue graph kind of follows like a upward motion, right? It's kind of like a cup shape instead of or a valley shape instead of a hill shape, right? This is what we call concave up. Right? Here, in the second part, we're kind of frowning shaped, right? Concave down. Right? And again, here in the third part, we've gone back to being this upward shape. Right? And look how this compares, right? So where the green graph is positive, right, in the first and the third part here, the blue graph is concave up. Where the green graph is negative, where the second derivative is negative, the blue graph, the original function, is concave down. All right, so think about how you could summarize that. All this information, in the next video we'll sum it up.